Imagine you're chatting online and suddenly wonder, am I talking to a real person or a clever chatbot? That's the essence of the reverse Turing test, turning the tables on Alan Turing's original idea and asking the AI itself to decide whether its conversation partner is human or machine. What makes this so tricky for AI? You might assume an AI can simply look for typos, slang, or emotional depth to flag a human, but modern language models can mimic those quirks flawlessly. Question: could an AI spot a bot by detecting perfectly consistent grammar or unnaturally quick responses? Answer: not reliably. Advanced AIs deliberately introduce imperfections and randomized timing to sound more human, blurring those simple clues. Instead, researchers explore subtler signals. An AI might probe for genuine lived experience. Say, what did you eat for breakfast today and how did it taste? Many human answers will include sensory details and spontaneous asides. The coffee was a bit too bitter, so I added sugar. Whereas a bot may scrape a recipe like description without personal flair. But savvy AIs can be trained on real world anecdotes too, making even that line of questioning less foolproof. Then there's the matter of consistency over time. Humans often change opinions or forget specifics, while an AI can recall every prior message perfectly. A reverse Turing evaluator could revisit a week old thread and ask you to summarize a past point. Yet some chatbots now store long histories and simulate forgetting to mimic human fallibility. Question: is there any signature no AI can hide? The answer for now is not yet. The cat and mouse game of detection and deception continues. Well, why does this matter? In customer support, we might want AI to recognize when it's unknowingly chatting with another bot, avoiding endless loops of automated handoffs. In social media moderation, distinguishing human trolls from bot farms could curb misinformation campaigns. And in ethics, we may demand that AIs identify each other and human users transparently, preserving accountability in digital conversations. Ultimately, the reverse Turing test challenges us to refine our definitions of intelligence and personhood. As bots grow more human like and humans lean on AI assistants to craft messages, the boundary blurs. So, whether you're the AI asking, are you human? Or the human wondering, is that AI? The quest to tell us apart is a fascinating frontier at the heart of tomorrow's online world. The reverse Turing test asks whether an artificial intelligence can identify whether its conversational partner is a human or another AI. This flips the original formulation by Alan Turing, in which a human judges whether they're speaking with a machine or a person. The reverse test becomes important in AI moderation, self-awareness, and secure authentication. In digital ecosystems where bots interact with each other and with people, such recognition could be a critical feature. It poses a new benchmark for AI perception and meta-reasoning. A chatbot is asked to monitor conversations and flag whether the user is a person or a rival chatbot pretending to be one. It's like a robot detective trying to figure out which party guests are real and which are cleverly disguised mannequins. As AI systems proliferate, they increasingly interact not just with humans, but with other AIs. Intentionally or unintentionally, distinguishing between entities allows systems to adapt tone, complexity, authenticity, or security measures. AI agents may need to prioritize humans for attention or verification, especially in customer service, content moderation, or surveillance. Failing to distinguish could lead to recursive loops, miscommunication, or even the spread of misinformation. The ability to tell who's real becomes essential in digital ethics and interaction design. A digital assistant receives a request that sounds human, but it is actually a prompt from another AI generating phishing attacks. It's like a receptionist needing to know if the caller is a real client or a robocall trying to sell something. Humans and AIs tend to differ subtly in language patterns, error rates, response timing, and contextual understanding. AIs may produce overly formal, precise, or statistically average responses, whereas humans make more grammatical mistakes, show hesitation, or use cultural references inconsistently. Advanced AIs can mimic these flaws, but the mimicry itself may become detectable through overcompensation. Behavioral cues like randomness, emotional nuance, and surprise can serve as weak signals of humanness. Training an AI to detect these markers is a frontier in meta learning. An AI may notice that a partner never misspells a word or gives responses faster than human typing would allow. It's like identifying a forgery because it looks too perfect. Flaws can signal authenticity. Yes, machine learning models can be trained specifically to distinguish between human and AI outputs using supervised data. Datasets of known AI-generated versus human-generated text can be used to build discriminators. This is already done in AI alignment research, deepfake detection, and plagiarism analysis. However, with improving AI models, the task becomes adversarial. As generators improve, so must detectors. It becomes an ongoing game of cat and mouse between creators and recognizers. OpenAI's classifiers attempt to distinguish between texts written by ChatGPT and a human writer using probabilistic analysis. It's like teaching a dog to sniff out counterfeit money. Effective until the counterfeiters improve their ink. Despite promising techniques, there are limits. Adversarial prompts, prompt engineering, and ensemble models can fool detectors. Subtle, long syntax conversations or stylistic fine-tuning can make AI outputs indistinguishable from human texts. Moreover, humans themselves vary enormously. Some speak like AIs, others like bots, making detection ambiguous. Biases in training data can lead to false positives or negatives. Ultimately, no model is perfect. Probabilistic guesses may replace confident recognition. A human deliberately writes in ChatGPT's tone using prompt-like sentence structures and gets flagged as AI. It's like trying to spot a robot in a costume party. Until someone acts robotic on purpose, a key question is whether an AI can know when it's speaking to another AI, not just detect patterns, but reflect on its own interaction context. This would involve a form of metacognition, reasoning not just about what is said, but who is speaking and why. Such reasoning is critical for AI alignment, preventing deceptive interactions, and detecting coordination between agents. A future AI that autonomously chooses strategies may need to model not only human minds, but artificial ones. In multi-agent systems, one AI may need to determine if another is independently optimizing its own goal or acting as a proxy. It's like chess grandmasters realizing mid-game that the opponent is not a person, but another AI thinking 6 moves ahead. Distinguishing humans from machines has major implications for cybersecurity, fraud prevention, and digital trust. CAPTCHA systems already rely on this distinction, but as AI gets better, traditional CAPTCHAs are becoming obsolete. A reverse Turing capability in AI could enable systems to automatically identify bots masquerading as humans in social media, voting, or e-commerce platforms. Conversely, AIs might also flag human users posing as bots for deception or misdirection. Identity in the digital world becomes a fluid, contested space. Social media moderation AIs could detect comment threads entirely generated by language models posing as real users. It's like checking IDs at a party where some guests are in elaborate disguises and others have stolen someone else's ID. If AIs can detect each other, should they be allowed to do so? And should they reveal that knowledge? There are ethical risks in hidden detection, such as biased treatment or surveillance of users based on presumed identity. Transparency, consent, and fairness become crucial. Humans interacting with AIs should know if the AI is judging their authenticity. There's also a philosophical question. At what point does an AI distinguishing minds imply it has one? As boundaries blur, questions of autonomy and sentience loom larger. An AI chatbot refuses to answer a user it detects as another AI, invoking policy against machine-machine communication. It's like a mirror refusing to reflect another mirror, each one recognizing the illusion in the other. The reverse Turing test challenges not only machines' ability to mimic humans, but also their ability to reason about identity, agency, and communication. As AI agents proliferate, their ability to detect, classify, and interact differently with humans and machines will shape future ecosystems. It's no longer just about passing the Turing test, but knowing when the test is being taken. Building AIs that can distinguish minds may be a step toward building ones that understand them. In this mirror game, recognition is the first reflection of intelligence. Future AI operating systems may routinely label users as AI or human, affecting trust, response style, and decision logic. It's like a game of poker where each player must guess, am I bluffing with a human or with another bluffing bot?